It's a pleasure for me to be here again, this time with a more structured presentation on how can we build an AI-ready energy grid and what is Portugal's path to this resilient and intelligent infrastructure. So my idea here will be today to give you the answer to these three main questions that I prepared in the presentation. So first one, who is Siemens Energy and why we are here today? Second one, what is really the Portugal's path to resilient intelligent infrastructure? And then the third one, and probably the most interesting one, why is it important to make the energy grid AI ready? But I'm sure most of you have several answers to this question. I'll have my contribution to it. So starting from the beginning, who is Siemens Energy? So Siemens Energy, for those of you who don't know, which I suspect there are not that many, is a global leader in energy business. So we are a spin-off, a carve-out, as we call it, from Siemens. It was back in 2020, so actually we're a 5-year-old company that has a legacy of 120 years here in Portugal with Siemens. So we are responsible for generation technology that generates 1/6 of global energy, electricity in the world. We are more than 100,000 people. Last time I checked, 104,000, I think. Present in more than 90 countries, and we're investing 1 billion euros a year on research and development. What do we do? So we have divided our business in 4 major areas. So you can see here on the lower zero emission power generation, so 2 major divisions, gas services and wind power on the renewable side. Then transport of energy and storage of energy, which is a division called Grid Technologies. And then 1/4 area called transformation of industry, where the customers are the industrial customers, and in this case, probably the data center industry will also be here as an industrial customer that needs a lot of power for their operations. It's a different type of industry, but nonetheless, it's an industry here. So as these 4 business areas, they represent altogether almost roughly 40 billion euros on annual revenue. So our annual results from last year are not published yet. We are now currently in the silent period, so we cannot share any detailed information on that. We'll be published in 2 weeks. If you are curious to see, we are expecting a yearly record again for the business, but as our stock has been raising 300% year on year for the second consecutive year. So let's see where it goes this year, but actually it's looking good. So gas service, roughly 10 billion, a bit above 10 billion. Grid Technologies, almost 10 billion, probably more than 10 billion for last fiscal year. Siemens Gamesa Wind Power, another 10 billion, and then the transformation of industry, 5 billion. This is a bit how it adds up in terms of business revenues from these different 4 business areas. Yeah? So where are we present? Mostly across the world, as you saw, more than 90 countries. But if you see, like 60% of it comes from Europe, Middle East, and Africa. Then America, roughly 20%, Asian, Australia, Pacific, another 10%, or 20%, sorry. We have been growing in terms of revenues, as I was saying. So last year, 34.5 billion. This year, it's expected roughly 8 to 10% growth. Let's see if we arrive to the 40 billion, not sure yet. And our profit margin has been growing also with the business. As you all heard, probably in 23 there was this issue with wind power generation from Siemens Gamesa. Had a huge write-off because of problems that we had in the wind turbines that is currently recovered and are coming back to the business nowadays. So how do we create shareholder value? So how do we position ourselves? So we want to be in attractive markets where resilience and growing, electricity demand is growing. It will be double by 2050. The world is getting more and more electric. In Portugal, to give you an example, only 25% of the energy that is used in Portugal is electricity. The other 75% is not electricity, it's gas and oil and other fossil fuels. So we were present in areas where the aging infrastructure needs replacement. Of course, you all heard it probably before. In the world, grids are getting older and older. Grids are a great constraint to connect all this new renewable energy and those new loads like data centers, for example. So all the infrastructure is getting old and needs replacement, and the pace of investment that is needed to cope with these replacements is really huge, and we are working a lot also in these areas. We want to work in places we have high entry barriers, complex projects that require really long-term experience. We are the ones that want to do the most difficult, demanding projects and not competing in other places where we don't have such a competitive advantage there, right? And we also have, of course, we want to have strong customer relationships, driven, last-longing customer relationships to make sure that we are still here. We've been here for more than 100 years. We want to be the next at least 100 years. So this is why we want to have really a long-term relationships with customers. Then we want to have also a resilient business model. a very huge backlog nowadays, more than 130 billion euros for backlog. So this means that if we stopped selling new products today, we would have like roughly 4 years of capacity still in our factories of products being built. So this is really a huge number, and we have to deliver on this because the market is also expecting that, right? And this is why you see lead times for transformers are growing more and more and more, and they're roughly 24 months, or gas turbines, they're also more and more, or syncons, or all these other products that are made in factories are getting more and more required. So we're trying to expand capacity as fast as we can, but still it's difficult to cope with the demand that we are seeing coming from the market. So we also have a very interesting part of service revenue shares. So 12.2 billion out of the revenue, like 1/3, comes from services with good margins working all these different areas. And then, of course, strong positioning. We want to be market leaders, first or second in the market. We want to participate in markets where we are not leaders. So if you see here in gas turbines, we're number 2 in the world. First one offshore wind, first one in grid solutions, second one in grid products. So present in many places with a clear strategy. This is what we do in Siemens Energy. Just to give you a more recent update on the figures. These are figures from Q3. So our Q3 closed in June, 30th of June. And you see the business is growing double-digit in terms of orders in all these different 4 segments. The revenue is also, most of them double-digit, here not so much. And then, of course, wind power is still being fixed. But in terms of profits and margins, we are really healthy at the margins nowadays. So 13% gas services, almost 16 in grid technologies, 11.5, and transformation of industry. So this is the problem that is currently being addressed with the wind power, but we are expecting to fix during this year. So this is what Siemens Energy is. I hope I gave you some global overview. Now I'm focusing a bit more what is happening in Portugal for the ones of you that don't know. Some of you might know it better than me. So actually Portugal has very ambitious energy transition targets. So we want to double renewables capacity by 2030. Some might say they are so ambitious that are behind ambition. This makes more wishful thinking. But anyway, this is the direction where we want to go. Double renewables by 2030, which is in 4 years. Having 80% of the electricity coming from renewables in 2026, and there are some good news on this area. Anticipate Portugal as a country to be carbon neutral by 2045, whereas most of Europe is targeting 2050. So, I mean, these are ambitious targets in the Portuguese government that then will drive all this development of renewable energy sources, and that technology is required for coping with that. So I'll give you a picture how it went last year. So good news, we had 80% roughly of renewables already to produce electricity. Mostly hydropower plants and wind power. They're like 1/3 hydro, 1/3 wind, and then bioenergy, solar, and a little bit, of course, fossil fuels still, roughly 11%, coming 7% from gas power, which is the lowest in the past 20 years. So if you look at the picture on the right side, you see how it has been evolving in the past 20 years. And of course, fossil fuels are decreasing more and more and more, and the wind is becoming the major source of renewables. But whereas the one that is growing more is sun energy. So PV, solar energy growing a lot. So more than 1 gigawatt of power installed only last year here in Portugal. And the fossil, of course, decreasing to historical minimums. So this is what it looks like in our National Energy Climate Plan for 2030. So it's a huge change between now and 2030 in the next 5 years. So actually passing from almost 30 gigawatts of power capacity up to almost 50 gigawatts. And most of the expansion, if you see, comes from solar energy, wind energy, basically. Those are the 2 main drivers. And you see here on the right side, oops, I hope it doesn't disturb you too much. The idea is to have 4 gigawatts additional wind, and 2 of them coming from offshore. Solar, now it's already more than 6 gigawatts, so passing from 6 to 20, which is interesting. And our country in 2030 should be fueled by solar and wind mostly, with some hydro complementing it. And of course, some backup generation. There are some days that there's no wind or sun is not shining as it should be, which is rare in Portugal. Yesterday was an exception, okay? And this will make electricity generation double, actually, basically the amount of energy coming from electricity in our energy matrix here in Portugal. So actually really pushing the country to become carbon neutral by 2045. So this is the plan. This is the master plan. And this master plan also opens opportunities for storage and for hydrogen. Because if you want to have so much intermittent renewable capacity installed, you will need to have also some loads that will be flexible enough to accommodate renewables and use the energy whenever it's available. Sun is shining, wind is blowing, let's bring this energy to some place, don't waste it. We don't need to curtail all this energy that is for free. Let's use it to charge batteries that we can use during the night or when there is a peak need for power, or produce hydrogen. So there are ambitious targets for hydrogen also here in Portugal. They used to be more ambitious, let me tell you, but they have been adapted a little bit. Still 3 gigawatts is still pretty ambitious. I don't know if you, for the ones of you who are Portuguese, for sure reckon this picture. It needs an update because these 2 chimneys have already been demolished 3 weeks ago or something. You can look it up in the internet, just implode them, because they are making this former coal power plant into a hydrogen power plant. This is the target from EDP here in Sines, which is next door to the Start Campus data center. So it's getting more and more sustainable in the region. Yeah? So now coming to the AI and data centers, and let's say the most relevant part of this. So probably this is the second day in the afternoon. You've seen this picture, I don't know how many times, 5, 10, whatever. So everybody's talking and quoting these studies. In this case, International Energy Agency and McKinsey. So global data center power will really rise in the next 5 years, 6 years, right? And Portugal, it's a very good candidate for installing data centers, as you all heard already today for sure, because we have all this renewable energy. The plans are really ambitious. The grid is not too old, but it still will need, of course, further development. Government is already approving additional investments in grids. Just to give you an example, the distribution system operator here in Portugal has approved a 50% increase in their investment for the next 4-year period. So this is really investing and getting more and more out of what we can do. Renewables on one side, and then all transporting and distributing all this energy for the right places. So of course, data center demand will grow. This is world, of course, a lot. So 4.5% of total generation will be driven by data centers, which would be amazing if it would be flexible loads, and they can be with the right solutions, but not only if you look at it as just a data center. You have to look at it more like an energy hub that has a lot of things to do. So data centers have a lot of challenges. Most of you know the challenge. You heard a lot about them for sure today and yesterday. One thing, there was somebody sitting here in a panel yesterday saying the top 3 priorities for data center: power, power, power. And of course, lack of power, it's the main issue nowadays. We see strong, fierce competition between different players to secure grid connection, because it's probably the best way to connect the data center, especially if it's renewable energy coming from the grid, which is the case most of the time here in Portugal. So 80% of the energy is coming from renewable sources. So this is a good, sustainable story to speak and to have a data center powered here in Portugal, like such Campus is doing, for example, right? Then you have this cooling challenge also. A lot of different technologies, liquid cooling, air cooling, seawater cooling. So all these different aspects are also needed to be taken in consideration. Sustainable energy use, what is the carbon footprint of the data center? Space constraints, some places this is a higher constraint than in other places. Permitting, this is always a pain, right? You have to license everything to make sure that all have all these different papers. Somebody was yesterday also talking about papers. So papers are, unfortunately, an important part of the process. But of course, everybody wants to be fast in building it. Everybody wants to go to the market and beat the market and be the first one to arrive. And this requires securing power, cooling solutions, space, so all this, the terrains. So this is really a critical aspect here, and it's getting more difficult to get because lead times for products that will power the data center are getting worse. So this is the challenge that we are having nowadays. Reliability, redundancy, of course, everybody wants that the data center works all the time, uninterruptedly, which normally happens if you're connected to the grid, except the last 28th of April, where you have a blackout in Iberia, and then backups had to work to improve reliability, ensure that service was still working continuously. Then, of course, wasted energy. How much heat are we losing in the data center? Are we heating atmosphere, or are we using the heat coming from the data center with some kind of combined heat power solution so that you can reuse the heat coming from the data center into some kind of energy solution to repower the data center or do something else with that energy? Or district heating, for example, was one of the solutions we're building in other places, not so much in Portugal. Then modular construction, you don't want to build your data center, the whole thing first time, just do it by modules. So being able to do this is also a very important thing for, especially to be fast in the market. And another very relevant topic is load fluctuation. As far as you have seen, it would be amazing if data centers' energy profile consumption were flat, but unfortunately the answer is they are not. Depending on the type of applications that data centers have, they might really fluctuate a lot, especially if we talk about AI data centers, go from 0 to 100 in a few minutes, seconds, depending on the application. But this is a nightmare of grid operators, right? Nobody wants loads floating at so fast. And this has really an impact in the grid and the stability of the grid, and lack of voltage control caused the blackout. Imagine if you have, I don't know, 1, 2, 3, 10 data centers changing constantly their power profiles and consumptions in the grids and injections, and so they'll be make these people working in grids really, really uncomfortable, to say the least. Yeah. So these are the challenges, and for achieving this and to try to solve and finding solutions. So Siemens Energy is developing a lot of technologies. Of course, there is the data center, the warehouse where things happen, where the servers are, the NVIDIA GPUs processing, whatever. But outside of this house, a lot of stuff happens. There was a picture yesterday, I don't recall, I think Ron from NVIDIA showing the Stargate in Texas. So it looks like a factory, actually, right? So there's a lot of building blocks to this, and one of them is the data center. It's probably the heart where let's say, the magic happens. But to ensure that the magic happens here, you have to have, or you can have, a lot of different things. So you might need probably a grid connection, or most of the cases you'll need a grid connection if you are able to get one and secure one. Not in 5 years, not in 10 years, as fast as you can. It's next year, in 2 years. In some cases, you already have it. You are reusing old coal power plants which already have a grid connection, for example, or something else. In other cases, you want to build one from scratch, and it will be more difficult. But we are working in this area, supporting grid connection of data centers, transformers, grid connection, integrating renewable energy near the data center, wind power, solar power, whatever it's needed. Of course, then you might need an industrial grid solution inside the campus of the data center if you have other applications that are not only the data center. You can produce hydrogen and store, if you will. You might have own production for renewables, and you might not use it all the time, or the load is too low in the data center compared to the generation that you are having. So in this spare time, you can produce hydrogen, for example, and storage in the tank, and then use a fuel cell later on to power again your data center and save some costs in the moment that you're not using the energy that you are producing yourself. Because the alternative would be to sell it to the grid, which is also possible, but in sometimes that might not be the best solution. Then you might also want to have your own power generation, gas-fired turbines. You might want to have its base load based on gas turbines, and we see this a lot happening nowadays in the US, in North America. So a lot of the customers, they want to have their own generation. They don't care, okay, the grid will take 5 years. I don't care, I'll have my own combined cycle power plant next to the data center, 100% dedicated to use to the data center. If I'm not operating the data center, I might be able even to sell this power to the grid and make some profit out of it. It's different business models, not something that traditionally a data center operator would want to do, but it might be a good complement for the business that you are on. Then, of course, also backup power, smaller turbines, gas turbines that are fired only whenever they're needed, or for peak application. I'll show a bit more on that. Then you can have storage, also electrical batteries, so BESS systems, and STATCOMs. And this could be very, very useful applications to stabilize the grid. So namely, to avoid those intermittent profiles and the data center processing that will not, let's say, affect the grid operator. If you have storage, you can accommodate these fluctuations within your storage equipment, within your STATCOM, to make sure that you have, let's say, a more interesting profile of consumption towards the grid or even generation, so that you can ensure that everything will run smoothly without blackouts, sorry. Then there is also waste heat utilization. I was talking about this, CHP, so combined heat and power. Some heat coming from the building of the data center might also be reused. It might be fed in some case, in district heating, or fed back to the grid, depending on the application. So you see, this is a whole ecosystem with all the different parts of the puzzle that must work together to ensure that we have a robust energy solution to power the data center. So we, from Siemens Energy, we are in front of the meter and behind the meter. We are working with the grid utilities, the large TSOs, DSOs across the world, of course, where they have utility scale generation, storage, transmission distribution. We are working with all these guys. And of course, also behind the meter. If the data center operator wants to have its own IPP, either owned by the data center operator or some third party that is providing 24/7 power generation in the data center, both solutions are possible, and the combination of those solutions is also possible. And we are supporting customers in both sides of this area. Then we want to have a stable and decarbonized grid connection. We want to ensure that we maximize the amount of renewables that we use into our data center, and we want to ensure that the grid is stable. So we need resilient grid connection and robust grid connection without uninterrupted power supply. So we are providing low-loss transformers, so reducing losses of energy, which is interesting. SF6 free portfolio, so we're reducing greenhouse gases emissions kind of products. Battery storage systems, all of this together also enable decarbonization of the operations for the data center and stabilize extreme power fluctuations, which is really, really helpful to convince a grid operator to speed a bit the connectivity of the data center, because they will feel the confidence that the data center will not jeopardize the grid operation, but will at times also support the grid operation. They are flexible enough to provide something to the grid, and I think this is something that is really valued from the grid operators, becoming more and more valued nowadays. So you see there's a lot of different products and solutions that can be used for stable and decarbonized grid solutions. If you go to the backup power, also different solutions you can have here. So hydrogen, STATCOM, BESS, small gas turbines, the ones that you're only using at peak times. You can have your own grid connection, but you need a bit more power than you were expecting. If you have this kind of applications, you can raise a bit the consumption that you're having, peak energy demands without disruptions, and also, as I was saying before, to stabilize the grid. So sending power to the grid whenever the grid requires additional support. And this would have been very helpful to avoid the blackout that we had here in Iberia a few months ago. Again, the same with storage and hydrogen fuels. It's another technology to be here. Then baseload. Baseload is the one I was talking about. A lot of people from the US, they really want to have their own combined cycle power plant next to the data center and use it like that. Doesn't matter if it's behind the meter or in front of the meter. So, and they can buy all different sets of sizes of turbines. We have a huge portfolio in this area and a lot of experience working with that. So this is one of the, let's say, most sought kind of products if you want to build a data center, at least starting in off-grid sites. Some examples, some customers, they have required grid connection. They told him 5 years. I said, we cannot wait 5 years. We cannot wait more than 24 months or 2 years. So I'm going to go with this kind of solution, and then we'll see later on we have a grid connection if you can replace it. Buy smaller turbines, something that is mobile, you can reapply another location if it's needed. So this is a good way to speed up the process. It's not the most sustainable way. There might be also carbon capture solutions to put on top of the gas turbines to ensure that the CO2 is not wasted and doesn't go away. But these are the solutions that we are seeing that are working a lot. So this is just a short slide to 1 second to say, if you see we have turbines from 600 megawatts down to 2 megawatts. You can choose whatever you want from the portfolio, depending on the needs, where you are, what you want to do, if it's baseload, if it's peak applications, grid resiliency. We are seeing this one, where is it? The A5, this SGT A05, 4 to 6 megawatts as a good combination of having several of these smaller turbines to power peak applications and grid and backup services for data centers. It's not cheap. You need to have gas on site, but it's one of the best solutions in case you can do that. And you see here some examples from customers around the world. So 3 of them coming from the US, of course, using gas turbines. This one, the big one, 1.2 gigawatts, same size as Start Campus here in Portugal. They just want to use 2 SGT 9000 HL, so very big combined cycle power turbines. Base load for data center. I just want to be independent from grids. I want to do my own thing. On-site base load, grid addition also, these 900 megawatts, 100 megawatts, smaller size turbines, but still pretty much the heavy stuff that you get to produce huge amounts of power. And then you have this for on-site backup. So this is an Equinix project in Ireland, 45 megawatts. They're using 9 of these SGT A05 turbines. So this is additional capacity to meet growing demand and to be fast to put it to work. So my colleagues told me these A05 turbines may be deployable in 12 to 14 months. So this is already within the scope that the data center would need to fast deploy power. One word on sustainability. So sustainability also comes from the way you look at these things. So within Siemens Energy, we're really working to improve the power system efficiency, because the problem of not being efficient is wasting energy, basically through the forms of heat or whatever, yeah? So in our portfolio, really working on the grid side, on energy stabilization, on the energy generation and storage to become the most efficient as possible, of using AI-enhanced digital tools, testing reliable products, having very good and very high maintenance engineering expertise here. Then decarbonizing also the grid connection on these different scopes. I mean, I don't know how much you're into sustainability, so direct emissions, indirect emissions, embodied emissions, trying to reduce across the value chain, all these types of different emissions, so that, of course, in the end of the day, we are reducing the carbon footprint of all the ecosystem. And providing future-proof technologies, trying to bring clean air, F-gas-free solutions for switchgears, in this case, for GIS, battery storage systems, to capture the clean energy whenever it's needed, and of course, gas turbines, flexible gas turbines, that are air-cooled in this case, so that you don't even need to waste water or use water for them. So the whole value chain, I was saying, the complete life cycle support, so from the raw materials, ensuring that the sourcing is done in the right places, manufacturing, 100% green electricity in the factories also, of course, we have to do that. I mean, otherwise, what are we trying to achieve? Distribution installation, product use, end of life, thinking about what will happen in 20, 30, 40 years, depending on the product life cycle. For example, distribution, transmission, transformers, they are assets that will be there forever. Actually, I was working in a grid operator before joining Siemens Energy. We removed a transformer from Lisbon, like 1 kilometer away from here, and it said 1952 was the date of installation, and it happened like 2 years ago. Like almost 70 years working there. And it was still working, but it was already a bit dangerous to keep it running for maintenance issues. It's in a historical location, so you really have to shut down the whole square to get rid of the transformer and put something else inside. So that's what we did at that time in EDP. So all these considerandos are key aspects that to take into account to make sure that we get as most sustainable as possible. Here an example for an air-insulated switchgear AIS substation. So this is a typical use case that we have been using here for 111 to 20 kV substation. From cradle to gate scope, the target was to reduce emissions, and of course, I think the figures there are 20% emission reduction if you work on all these different aspects that are emitting CO2 or greenhouse gas into the atmosphere. So it's HV, AC area, medium voltage distribution system, which is not so much. The transformer itself is an important part of it, of course. Stabilization station services, grounding, cabling, all that is also important. And civil works also competing with the transformer, which are the ones that are more stringent in what regards CO2 emissions. So having this present in our supply chain in the way we operate and manufacture, it's also important to ensure that in the end of the day we minimize the impact and working with a 20% reduction nowadays for this. Coming to an end, yes, we have this diverse portfolio working in different areas, as you saw. This is a very large and broad portfolio, either working in efficiency increase with all these different technologies, fuel shift hybridization. One thing I didn't mention are some of the gas-fired turbines are dual fuel and are already some of them prepared for hydrogen. So if we have in Portugal green hydrogen and we have fuel turbines ready for hydrogen, that would be a good way to have a renewable source powering a gas-fired turbine with all this flexibility that you get from there. So this is also important here. Of course, other topics from deep decarbonization, like this blue portfolio, SF6-free gases are really important aspects here. We believe there are three aspects. It's a triangle, so how to square the circle. That's what we normally say, right? Here we want to square the triangle, so we need affordability, reliability, and sustainability. These are the three aspects that we really need to tackle to make sure that we make a successful energy transition and that everybody is on board and not hindering future generations in the world. So to finish, I mean, coming together is the beginning. Quoting my friend Henry Ford, keeping together is progress, working together is success. And this is why we're here for, to work together with all these different partners to ensure that we achieve these noble goals for our future generations to come. Thank you very much from my side. It was a pleasure to be here. Appreciate it. Thank you.